Hello everyone. In this lecture, we will solve an interesting question that has been asked in UPSC CSAT 2020, right? The question is, how many pairs of natural numbers are there such that the difference of whose squares is 63? So if we assume that those two natural numbers are x and y, we are assuming that those two natural numbers are x and y, right? And it has been given that the difference of whose squares is 63. So can we write x square minus y square, that is equal to 63. So basically, can we write it as x plus y into x minus y, that is equal to what? That is equal to 63. Why did we write x square minus y square as x plus y into x minus y? Because since childhood we have using a formula a square minus b square, that is equal to a plus b into a minus b. So similarly we have used that formula here. So now tell me that how can you write, see, if x and y are natural numbers, if x and y are natural numbers, right? So one thing is sure that x plus y will also be a natural number, and x minus y will also be a natural number, right? Obviously the condition is simple, that x is greater than y. Then if you do x minus y, then you will get x minus y as a natural number. But don't think about those things. Tell me, can you write 63 as 21 into 3, right? Can you write 63 as 63 into 1? Can you write 63 as 63 9 into 7? So we have written 63 as the multiplication of two natural numbers in three ways, right? So if you have solved this kind of questions earlier, you will be able to answer that three pairs. Option 1 is the correct answer. But if you are not able to think at this point, don't worry, we will come to that thing. See, if you do prime factorization of 63, you will write it as 3 square into 7. So from there you will be able to think that, okay, you can write 63 in this way: 21 into 3, 63 into 1, 9 into 7, right? Now if you look at this point, so can you write it as x plus y into x minus y, that is equal to 21 into 3. You should not have any kind of issue if I have written in this way, x plus y into x minus y, that is equal to 21 into 3. Similarly, if I write x plus y into x minus y, that is equal to 63 into 1, right? Similarly, we can write it as x plus y into x minus y, that is equal to 9 into 7. Now if I say you that x plus y is 21 and x minus y is 3, you should not have any issue. Why? Listen, x and y are natural numbers, so it is obvious that x plus y will be greater than x minus y. In one case you are adding two natural numbers, and in another case you are subtracting, right? So obviously x plus y will be greater than x minus y. So x plus y equal to 21, x minus y equal to 1. So you can write it as 2x equal to 24. So basically x equal to, if you add both equations, see, everyone solves these equations in his own way, right? But if you add these two equations, you will get 2x equal to 24. So x equal to 24 by 2. So x equal to 12. If you put the value of x equal to 12 in any one of these two equations, you will find the value of y, right? So let us put the value of x equal to 12 in this equation. If you put it here, you will find, see, I am putting it here. So 12 plus y equal to 21. So y equal to 21 minus 12. So y equal to 9. So you have found one pair. One pair is 12 and 9. One pair is 12 and 9. The value of x is 12 and the value of y is 9. Similarly, if you solve it further for other possible cases, you will write x plus y is equal to 63, x minus y equal to 1. If you add both of these equations, 2x equal to 64 plus y and minus y will cancel each other, right? So 2x equal to 64. So if you solve it further, x equal to 64 by 2, that is equal to 32. You can put the value of x in any of these two equations. If you put the value of x equal to 32 in equation x plus y equal to 63, you will be able to find the value of y. So let us put the value of x equal to 32 in any one of these equations. We are putting it in first equation, so 32 plus y equal to 63. So y equal to 63 minus 32, that is equal to 31. So you have found one pair again. One pair is 32 and 31, and you have found one pair, that is 12 and 9. Similarly, you can write it here, x plus y equal to 9, x minus y equal to 7. You can again find the value of x and y by solving these two equations, right? So x plus y equal to 9, x minus y equal to 7. If you add these equations, you will get 2x equal to 16. So obviously x equal to 16 by 2. So the value of x is equal to 8. If you put the value of 8 in any one of these equations, you will find the value of y. So let us put the value of x equal to 8 in equation x plus y equal to 9. So if we put the value of x 8 in x plus y equal to 9, 8 plus y equal to 9, so y equal to 1. So again one pair is 8 and 1. See, if you are good at maths and if you have solved this kind of questions earlier, once you write 63 as 21 into 3, 63 into 1, 9 into 7, you should be able to think that, okay, we can write x square minus y square equal to 63 as x plus y into x minus y equal to 63. Now we can write 63 as 21 into 3, 63 into 1, 9 into 7. So we are getting two equations in x and y, two equations in an x and y, two equations in x and y. So basically there are three cases. So why to solve? Why to solve further to find the exact value of x and y? You don't need to find that thing. You don't need to do that thing. You should be able to answer three pairs at this point. But don't worry, even if you do this thing, you are not going to lose anything, right? Obviously you will have to invest 1.5 minutes, 2 minutes more, but in CSAT we don't care a lot about scoring a lot of marks. Our first goal is to clear the cutoff, right? And you should be able to solve this kind of questions. And all of us know that number system chapter is very critical. So if you have to appear at CSAT 2025, you should focus on this chapter a lot, because you will get 15 to 20 questions from that chapter. Even the basic concepts of number system is helpful when you have to deal with the questions of data sufficiency, right? So hopefully all of you are able to understand that how can we solve this question correctly and quickly, right? If you are thinking that why can't we assume x plus y equal to 3 and x minus y equal to 21, see, it is not possible. Why? The reason is simple. Suppose if you say that x plus y equal to 3 and x minus y equal to 21, see, you are dealing with two natural numbers. So is it really feasible that sum will be less and subtraction case will be higher? No, it is not feasible, right? And you can even cross verify. See, 12 plus 9 is 21, 12 minus 9 is 3. And even if you can cross verify 12 square minus 9 square, you will get 63. 32 square minus 31, you will get 63. 8 square minus 1 square, you will get 63, right? 8 square is 64, 1 square is 1, so the difference is 63. Similarly here, 32 square is 1024 and 31 square is 961, so obviously the difference is 61, 63. Even in this case, 12 square is 144 and 9 square is 81, so again the difference is 63. But I will suggest you that if you solve this kind of questions after some practice, you will not do a lot of calculation. You will be able to stop yourself at this point and you will be able to answer that the correct answer is 3 pairs. 3 pairs of natural numbers are there such that the difference of whose squares is 63.